Part B on 10.5 conic section, we'll talk about hyperbolas. Hyperbola is defined as a set of points on the plane the difference of whose distances from two fixed points, f1 and f2, is a constant. The difference of whose distances from two fixed points, called foci, is a constant. Let's draw a picture. For convenience, we're going to have the hyperbola here centered at the origin and with the two branches like this. So the foci, let's call them F1 and F2. So any point on the hyperbola, let's call this P with coordinates x, y, have distance to these two foci. So the difference between those two distances, so PF1 minus PF2, this is equal to a constant, positive or negative. We'll call it plus minus A. So the equation derivation of hyperbola is very similar to the one we did for the ellipses. So we're going to write the equation now. If the hyperbola is centered at the origin, the equation is x squared over a squared minus y squared over b squared equals 1. So remember with the ellipse, this was plus, and here it's minus. However, c squared, in this case, is a squared plus b squared. It was a squared minus b squared for the ellipse, so it's a little different. The x-intercepts are plus minus a, and that is exactly this point here and here. And a0, negative a0 co-vertices. So this is this point here, that is a and negative a. If we put x equals 0 in the above equation, we'll have y squared equals negative b squared, which is impossible to have a square equal to a negative number. Therefore, there are no y-intercepts. No y-intercepts in the hyperbola. Hyperbola is symmetrical with respect to both x and y-axis. All right, so if we solve for x squared over a squared from the above equation, we have 1 plus y squared over b squared, which is definitely greater or equal than 1. So we have x squared over a squared greater or equal to 1, which means x squared greater or equal than a squared. And if we solve this, we have absolute value of x greater or equal than a, and we solve that, we have x greater or equal than a or x less or equal than negative a. So hyperbola consists of two branches, or two parts. Let's just write this down. Two parts called branches. So one branch is when x is greater or equal than a, the other one x less or equal than a. When we draw the hyperbola, it is useful to draw its asymptotes. So let's demonstrate this here and construct a hyperbola roughly like this. We talked about vertices here. This point here is 8, 0, and this point is negative 8, 0. The foci, so F1 is here with negative C0 and F2, C0. We also have asymptotes that can help us draw. These are oblique or slanted asymptotes. And the equations of those asymptotes are y equals b over a x, y equals negative b over a x. So let's write this down. Everything we know about this, we know the equation of the hyperbola. We know the foci, we label them plus minus c and 0. We know vertices, plus minus a and 0, and asymptotes, 2 of them, and the equation, so y equals plus minus b over a x. Because of the symmetry, we can combine the 2 foci, the 2 vertices, and the 2 asymptotes. And let's not forget c squared here is a squared plus b squared. So if the foci of the hyperbola are on the y-axis, if the foci of the hyperbola are on the y-axis, so far we saw them, they're on the x-axis, and so are the vertices. Then by reversing x and y, we obtain, by reversing or switching x and y, we obtain the following equation: y squared over a squared minus x squared over b squared equals 1. So in this case, the foci, they're along the y-axis, so 0 plus minus c. The vertices, again, along the y-axis will be 0 plus minus a. The asymptotes, those slanted lines, will be y equals plus minus a over bx. And finally, c squared is a squared plus b squared. That doesn't change. So let's draw the picture here of this hyperbola. See if I can fit it here. So this is the x and the y-axis. And in this case, this hyperbola, the 2 branches, they open up and down. So we have vertices right here, 0a and 0, negative a. We have foci, and they are here at c and negative c, or you can write this as a pair, 0, negative c if you want, 0c. And the asymptotes, right here, and the equations of those asymptotes, we say y equals a over bx, and y equals negative a over bx. Okay, so we had labeled everything. Now, couple examples. Find the foci and the asymptotes of the hyperbola with equation 9x squared minus 16y squared equals 144, and then sketch it. So we start with our equation, and we need to rewrite it so it fits our formula. We're going to divide all terms by 144. We want to get 1 on the right side. So 9x squared over 144 minus 16y squared over 144 equals 144 over 144. Cancel and simplify, and we have x squared over 16 minus y squared over 9 equals to 1. So from this equation now, we can figure out what a is, and that is 4, because denominator is a squared, so a is 4, and b is 3. So we can find c squared equals a squared plus b squared. 16 plus 9 equals 25. So c equals 5. If c equals 5, then you know the foci would be at, let's write both of them together, plus minus 5 and 0, or you can write them separate. The vertices are at plus minus 4 and 0, and the asymptotes. So y equals plus minus 3/4 x. So the equation was b over a, so 3 over 4x. So we're ready to sketch this hyperbola. We're going to start with sketching the vertices. So 4 and negative 4, the vertices. And the foci, they were at 5 and negative 5. So we can label them if you want, F1 and F2. And asymptotes, you have up 3 over 4, y equals 3/4 x. And the other one, usually we draw them dotted, negative 3/4x. Okay, so we have everything labeled. Another example. Find the foci and the equation of hyperbola with vertices 0, plus minus 1, and asymptotes y equals 2x. So we have to do two things, the equation and find the foci. So from the vertices, we can say a is equal to 1, and from the asymptotes, we have a over b equals 2. You notice the vertices are along the y-axis, okay? So we have the second equation to deal with. So the second equation is this right here. The equation that we need in this case is y squared over here, y squared over a squared minus x squared over b squared equals 1. So we have a is 1, a over b is 2, which brings us to b equals 1/2. And c squared is always a squared plus b squared for hyperbolas. So that is 1 plus 1/4 equals 5/4. So c is equal to square root of 5 over 2. And we can find the foci. They're going to be along the y-axis, so they'll be 0 plus minus root 5 over 2. If the vertices are along the y-axis than the foci are along the y-axis. And so finally, we can substitute and have y squared over 1 squared minus x squared over b squared will be 1/4 equals to 1. We'll multiply by 4. And we have the equation y squared minus 4x equals 1. So another thing we want to go over here, number 4 in our section, is shifted conics. So far, our examples of ellipses, hyperbolas, and parabolas were always centered at the origin, but now the center can be anywhere. So point xy can be in a standard equation, can be translated to another point x minus h, y minus k. So let's do an example, this time with an ellipse. So find equation of an ellipse with foci 2, -2, and 4, -2, and vertices 1, -2, and 5, -2. So we don't have to sketch it. You could if you want to. You just have to find the equation. So the major axis, I need to write this down, it's very important, that the major axis joins the vertices. So if you have the two vertices somewhere here, 1, -2, this is not drawn to scale, just to imagine, these are the two vertices. Okay, the distance between them, that's from 1 to 5. This distance is 4. Okay, so what does that tell us about A? If the distance is 4, halfway would be A. So A is 2. Now, the distance between the foci, so the two foci, sorry about the pause. So the distance between the two vertices is 4, so A is 2, and the distance between the two foci is from 2, -2 to 4, -2. That distance is 2. So what that means is the C is 1. And now we have the equation c squared equals a squared minus b squared. We're talking about ellipse. So that's the equation. So b squared is equal to a squared minus c squared. So that is equal to 4 minus 1, or 3. So b squared is 3. The center of the ellipse is at 3, -2. So the equation now becomes x minus 3 squared over 4 plus y plus 2 squared over 3 equals 1. Another example, and that'll be the last one. Sketch the conic. (9x squared minus 4y squared minus 72x plus 8y plus 176 equals 0. Find its foci. So first thing we're going to do is complete the square and rewrite the equation so it looks familiar. I'm going to move some terms So I want y to be positive, 4y squared minus 8y. In other words, I'm going to move this term on the other side. So 4y squared minus 8y minus 9x squared plus 72x equals 176. So rewrite this. We're going to factor out 4 from the first two terms. I'm going to leave some space here for the completing of the squared. Minus 9x squared minus 8x, leave some space, equals 176. So now we're completing the square. We're dividing this 8 by 2 and squaring it. So 8 divided by 2 is 4. Oh, there's something wrong here. So we should not factor, or I did not factor correctly. So let's do this again. Let's do this again. We're gonna group them first. So factor out 4, but this will be minus 2y. That was the problem. Minus 9x squared minus 8x, leave some space, equals 176. So now we're going to complete the square. We're going to add here 4. 2 divided by 2 is 1 squared. 2, let's see. No, we're going to add 1. We need just to add 1 here to complete the square, and here we need to add 16. 8 divided by 2, 4 squared, 16. We need to do the same thing on the other side, so plus 1. Actually, because we added 1 here, but there is a 4, so we need to add 4 on this side, and we need to subtract 144, which we obtained by multiplying 9 times 16. Okay, so now we have 4 times the quantity of y minus 1 squared minus 9 the quantity of x minus 4 squared equals, if you simplify the right side, it's 36. So let's divide by 36. And we have y minus 1 squared over 9 minus x minus 4 squared over 4 equals to 1. This is the equation. And we can recognize this is hyperbola with a shifted center. So the center of this hyperbola is 4, 1, 4, 1. And a is 3. That's a squared is 9, so a is 3. B is 2. C, how we're going to find C? So we have c squared equals a squared plus b squared. C squared is equal to a squared plus b squared for a hyperbola. So that's 9 plus 4. So c squared of 13. So now we can write the foci. That will be, because of the shift, see the center is 4, 1. So the foci will be 4, 1 plus square root of 13. And the other one, 4, 1 minus square root of 13. We have vertices. 4, 4, and 4, negative 2. So you have to consider the shift. And asymptotes, y minus 1 because of the shift. So the center being 4, 1 is very important here. Y minus 1 equals plus minus 3 over 2, x minus 4. And finally, the graph of a hyperbola. First, we'd start with the center. So the center was 4, 1. So let's say it's somewhere here. This is the center 4, 1. You can sketch the dotted lines of the asymptotes first. Okay. And so the hyperbola looks like this with vertices. That was 4, negative 2. And the other one was 4, 4. Of course, the foci, need to mark the foci. So we had 1 at 4, 1 plus root 3. I'm just going to like them F1 and F2. And that concludes this part B.